Hello, here we will talk about graphical presentation. So, graphical presentation is very important whenever we are going to summarize the research finding. Some of findings we need to present with help of the different kind of the graphical presentation which may help to visualize the data. So first of all, graphics are diagram. We need to understand. So first we'll define the what is the diagram. So diagram is a visual form of presentation of statistical data highlighting their basic facts and relationship. This is basic meaning of diagram. Now we'll discuss point wise. So what are the significance of diagrams and graphs, why it is required? So diagram and graphs are extremely useful because of the following reasons. They are attractive and impressive, and graphs and diagram make the data simple and intelligible. Diagrams and graphs make comparison possible. Diagrams and graphs may save time and labor. Diagram and graphs have universal utility, and diagram and graphs give more information and have a great memorize effects. These are the significance for that point of we need to create the graphs diagram. Now there are different types of the diagram. Once we'll go through different software or Microsoft Office Excel, so we can create a diagram in different dimensions like one dimensional diagram or two dimensional diagram or three dimensional diagram, or somewhere if we see the no there are some pictograms and cartoons. If we see the news and modern presentations, so somewhere we can use pictograms and cartograms. Now we'll go for the one dimensional diagram, like how to create line diagram, simple diagram, what is the multiple bar diagram, what is subdivided diagram, percentage bar diagram, different nomenclatures. So we'll discuss one by one. So line graphs or line diagrams we can create like data having some order, such as the year wise, immunization coverage, or age wise incidence of disease can be represented by a line diagram. Line diagram means this is the vertical line and this is the horizontal line, this is the x-axis, this is the y-axis. So, and here some value will put like value of the x and value of the y. So at different here x-axis would be the different value and y-axis will take the different, and it will be the different value with help of the data set. So some points will plot like this and will create the data like this, and it may be some kind of the graphs known as the line diagram. Or here if we see the number of children's and frequencies, some family members means there are 10 family members having 0 children, 14 family members having 1 children, and 9 family members having 2 children, 6 family members having 3 children, 4 family members having 4 children, and 2 family members 5. So this x-axis, this is the number of children, and this is the y-axis frequency is given, and this is the line diagram we can create like this. So this is known as the line diagram. So like that we can go for next kind of the diagram. So qualitative bar diagram. So how to create the bar diagram? So qualitative or categorical data can also be represented by another diagram called the bar diagram. In this diagram, we show the category of the variable on the x-axis and the frequency on the y-axis on a graph paper, and a bar for each category of the variable is erected, and the height of the bar is proportional to the frequency of that category, and each bar should have an equal width. Since the data is of a qualitative nature or discrete, bars should not be next to each other, and there should be an equal gap between two successive bars. So this is the basic concept once we are going to create the bar diagram. Now we have a data, we can see this is the bar diagram. Year and production in tons in 1991 40 tons, and 92 45 93 55 94 45 42 95 50. So these data we can put in the Excel file, and x axis we can put the year, and y axis we can put the productions. For each years we are getting the each for each year we are getting the different bars. See, the each colors are different, representing the different year, and this value is representing the frequencies for that year. So this is the simple bar diagram we can create easily with help of the Microsoft Office Excel. Now next point is the adjacent bar diagram. So adjacent bar diagram can be extended to compare two or more data sets of a qualitative nature with regard to the same variable. The bars of each category of the variable for the different data sets are down adjacent to each other. The principle of bar width and the gap between the bars will remain similar to those in the simple bar diagram. This is the basic concept we need to understand. Now this is the point. See, year is given, profit before tax is given, after tax is given. For each year we have to create the two bars. So this is known as the adjacent bar, multiple bar diagram. For each year we are getting two bars. So two profit before tax and profit after tax we are getting. In this way we can create with help of the Microsoft Office Excel. Once we'll put the data and we can find out these graphs easily. The one column we have to put the year, second column we have to put the these values, third column will have to put the value, and we'll select all the, we'll go in insert, create the bar diagram, and we can find out it easily. This is a simple way to find out the multiple bar diagram, or we can say adjacent bar diagram. Now next point is the component bar diagram. The adjacent bar diagram does not convey anything about the similarity of the relative proportions of each type in the two centers being compared. To depict this aspect, we can represent the data in another form of the bar diagram called the component bar diagram. As the name indicates, the component data from the bars being compared. So we can get more clarity with help of the examples here. See here expenditure items like food, clothing, educations, house rent, miscellaneous. Now each family member have a such kind of the expenditure. So here we are comparing two family members, family A and family B. Each family's expenditure, monthly expenditure given in rupees. Family A 75, family B for food is a 95. For each item the expenditure is given. So here we can create this subdivided bar diagram, family A and family B. So someone is creating like a food items and clothings and house rent, educations, and no miscellaneous. So we can say family A, this is the component bar diagram, subdivided bar diagram. So same way we can see here factory A and factory B. We have each factory have a selling price, quantity sold, wages, materials, miscellaneous. So for each factories have a different uh, selling price is given, and for each item. Now for creating the component bar diagram, For factory A, this item is given. We have to calculate the percentage for each item here. And same way for factory B, we calculate the percentage for each items here and we'll plot it through the graphs. So this is the factory A and this is the factory B. And this is the miscellaneous item. This is the materials. This is the wages. This is the quantity sold. And this is the selling price. So this way we can create a graph with help of Microsoft Office Excel, which is known as the component bar diagram or percentage bar diagram. Somewhere we are putting the, we can frequency we can put and create the graph, or we can put the percentage and create the bar diagram. So this is the way for component bar diagram. Now we'll discuss about the pie chart, which is very important. We need to understand it is very useful in the research. The pie diagram is generally used to represent qualitative or categorical data. Before beginning to represent the data by a pie diagram, we should have the frequency of different categories at hand. For each category, find the proportionate degrees of the total of 360 in the circle. For example, if a category has a 25% frequency of total, it should be allotted 25% of 360 or 90 degree. So a sector with 90 degree to represent this category of the variable. We can have more clarity. Suppose we have a given a data like blood group is given, group A, group B, group AB, O. This is four group, blood group is given, and for each group frequency is given here, and we can calculate out of total, we can calculate the percentage of the blood group for each group out of 100%. So out of 100%, we can create the pie diagram. For C, each percentage we can create and total percentage should be 100. Then we can create the pie diagram, and for each group we can create the degree angles of the this segments. Like blood group A, which is 15, if you see here frequency, so we can create with help of the frequency and with help of the percentage both. So here see frequency, we can create 15 out of 9 into 360, we can calculate the 60 degree. And group B, 25 divided by 90 multiplied by 360, which is 100 degree. And if you see the percentage 16.7, this percentage which is 16.7, and circle, this is centered degree, which is known as the 360 degree, multiply 360 divided by 100. So for this segment, this angle we can say which is 60 degree. And same way for this. So what is, how we'll get this angle? So we can calculate this value 27.8 multiply 360 divided by 100, and this is the 100 degree. So we can say this angle is the 100 degree. This is the way of calculation, and this is the concept behind creating the pie diagram. And we can create this diagram with help of Microsoft Office Excel. We can put the data there and we can get the diagram. Now next point is some graph which is very important for presentation of statistical data. And in statistics, very important very important diagram which is known as the histodiagram. Histodiagram is very important to understand the normality of the data. And second, frequency polygon, and third, ogive. Now here quickly we'll discuss how to create the histodiagram, frequency polygon, and ogive curve. So the most popular of all diagram is the histodiagram, and which is used to depict the frequency distribution of a quantitative variable. The class intervals are shown on the horizontal axis and corresponding frequency in the form of vertical bar diagram. So we need to understand this is the horizontal line which is known as the x-axis, and this is the vertical line which is known as the y-axis. So we need to understand, and this is the origin point. The width of each bar need not be the same, as it depends on the width of the class intervals. Now see here, daily wages and number of workers. Suppose in a hospital, daily wages 0 to 50 rupees, 8 workers 55 to 50 to 100 rupees, 16 worker 100 to 150 workers 27, 150 to 200, 19, 200 to 250, 10, 250 to 30 is a 6. Suppose this is the data is given how to create the histodiagram. So this is the continuous data 50, and other way class, this is the exclusive class type of the interval is given, corresponding frequency is given. We can put this data and we can find out the daily wages here, number of workers here, and this diagram is known as the histodiagram. So we can create easily. Now some other kind of the data. Suppose if we have an inclusive class type of the data, inclusive class type of the interval, and for each intervals corresponding frequency is given, like out of 80 marks, number of students are getting different marks, then how we'll create the histodiagram. So for this data, something is different because this is the inclusive class. This class is known as the inclusive class interval. So for that, first of all, we need to create the uh, continuous format like this. See this data. So we'll find out the difference between this upper limit minus this next class lower limit minus previous class upper limit. So difference would be 1 divided by 2. So we'll take whatever 0.5 value. So we'll add here 0.5 and we'll subtract 0.5 each in class interval. Then we'll get the continuous class interval, which is known as the exclusive type of the class interval, and corresponding frequency is given. Once we have this exclusive type of the class interval, then we can create the histodiagram, which is very important. We need to understand. Now, next point is the frequency polygon. To facilitate comparison, another diagram called the frequency polygon is used. This diagram is made by simply joining the midpoints of the tops of all the bars with a straight line and then removing the bars. It is fairly easy to draw and useful in comparing two or more distribution, as it can be represented on the same graph. This is about basic concept of the frequency polygon. We will understand with help of the examples like weight in kg. Suppose weight number of students is given 30 to 35, weight 4 students, and between 35 to 40 weight kg weight 7 students. Now 10 students have a belong 40 to 45, 18 students belong 45 to 50, 14 students belong 50 to 55, 8 students belong 55 to 60, 3 students belong 65 to 65. So this is the frequency is given. Now this is the exclusive type of interval, and will create this graph, and with free hand each midpoints will this free hand will move, and this center points will add. This is known as the frequency polygon. So now one last graph, which is known as the ogive curve, as we have discussed during the cumulative frequency. So how to create less than ogive and more than ogive. So for a set of observation, we know how to construct frequency distribution. Require the number of observation less than given value or more than given value. Now, so there are less than ogive or more than ogive. We'll have discussed with help of the example. Now we have an exclusive class interval 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. And for each class interval, we have a different frequency 4, 16, 13, 25, 32, 19, 8, and 3. Let's understand how to get the frequency uh, polygon. Sorry, ogive curve. So class interval, as we know 10 to 20, then 22, 30, and then 32, 40, so 52, sorry, 40 to 50, like that, 90 to 100. So this is the class interval is given. For each class interval we are calculating here less than cumulative frequency and more than cumulative frequency. So if we see here, this is the original data. With help of that we are creating the this less than ogive curve. So 10 to 20, 0, 4, 4 plus next will calculate, and we can find out how to get the uh, less than ogive core and more than ogive core. For that, we need to see the cumulative frequency. We can understand and we can draw this x-axis, y-axis. If we are using the original graph paper, so for that graph paper, we can make this scales. We can apply this scale x-axis 1 centimeter equal to 10 units and y-axis is equal to 10 units. We can use this on graph paper and we can create this ogive curve. And main important value of the ogive curve, this cross point, and this is here cutting these points. This is known as the median value. So this is the basic points on graphical presentation we need to understand. One summary points we need to understand. Once data categorized in two parts, qualitative and quantitative. And if we have a qualitative data, we can create tabular methods, then we can create graphical methods, and in tabular methods we can calculate frequency distribution, relative frequency distribution, percent frequency distribution, and cross tabulation we can create. And for graphical presentation, we can create bar graph and pie charts. And again, quantitative data if we have, so we can create tabular methods and graphical presentation. And in tabular methods, we can create frequency distribution, relative frequency distribution, percent frequency distribution, cumulative frequency distribution, cumulative relative frequency distribution, cumulative percentage frequency distribution, and cross tabulation. Such kind of the analysis we can put in the tabular methods. And graphical presentation, we can create many graphs, like if we see dot plots, we can say histogram, we can create ogive, we can create stem and leaf display, we can create scatter diagram, we can create, and picto diagram we can create. So these are the basic summaries. Once we have a data, qualitative, quantitative, we can understand what we can do, which kind of analysis we can do. This is the overall summary of the graphical presentations. Being a researchers, we need all the concept. Thank you.